Greetings everyone, I am excited to remotely present this talk titled Impresión 3D a lo Cubano, 3D Printing the Cuban Way. First, a little bit about me. I am Maurice Haedo Sanabria. I am from Cuba. I am an industrial designer and co-founder of Copincha, a community lab and a hackerspace in Havana. At Copincha, we develop and share open source solutions for local challenges facing Cuba, such as resource scarcity and limited internet access. Additionally, I lead the Precious Plastic chapter in Havana, which I will explain in a moment. In this talk, I will share how Copincha has leveraged open source, DIY construction, and documentation practices to make 3D printing more accessible through recycling. This approach has sparked a wave of local plastic recycling in Cuba and allowed Copincha to develop and prototype new forms of 3D printing hardware despite the material limitations imposed by Cuba's economic isolation and extreme resource scarcity. It has also established new community networks around plastic recycling. After that, I will share my experience replicating this project at the hackerspace in New York City called NYC Resistor, where members have also embraced the importance of connecting plastic recycling and 3D printing. As you probably already know, plastic production is a global problem. Much of the problem stems from our culture of single-use plastic. In addition to recycling more, we should also reduce our use of new plastic. This is particularly relevant in countries like Cuba, where we face extreme resource scarcity, yet plastic is everywhere. It is also relevant in a different way in the United States, which is the country that produces the second greatest amount of plastic waste in the world after China. I mentioned Precious Plastic earlier. Precious Plastic is a collaborative network of people worldwide. They share knowledge, experiences, and projects, all related to plastic recycling using small-scale manufacturing machines and tools. Around the world, local Precious Plastic chapters contribute to a master map, or where to find people providing different types of recycled plastic products and services in any given location. At Precious Plastic Havana, we mapped the local plastic recycling network using the alternative open source softwares TiddlyWiki and OpenStreetMap, because the US embargo prevents us from accessing the global cloud-based map. Just one example of how open source technology is important for marginalized countries to be able to participate in global networks like Precious Plastic. At Copincha, we started using 3D printers in 2018, and that led us to get involved in plastic recycling for two main reasons. First, we were concerned about how much plastic waste the 3D printers generated, and we wanted to use more eco-friendly materials. The second reason was cost-related. Regular 3D printing filament in Cuba cost double or triple what is cost elsewhere because of our limited participation in world markets. So it made sense to explore ways to manufacture filament from existing materials. We started collecting plastic waste that would normally be discarded and instead converting it into filament. Copincha started teaching people how to classify plastic waste according its type and whether it can be recycled or not. We have taught dozens of people to classify plastic with the goal of improving local and small-scale recycling in the city. We also used open source projects for building machines that transform plastic bottles into 3D printing filament, like the Recreator 3D, Polyformer, Petamentor, and Petalot. These projects are based on a manufacturing method that involves cutting the bottle into a long strip and passing it through a hot nozzle to reshape it into filament while a winder continuously pulls and winds it. To generate the amount of 3D printing filament that we needed, we had to find a steady source of discarded plastic bottles. We visited workers in Havana who collect plastic bottles, clean them, and then sell them to stores that reuse them. We offered to purchase the bottles at a better price than what they receive from the stores. Then we started teaching people from all walks of life how to build and use 3D printers and other recycled plastic machines with materials they can find easily. The collective learns a lot from each attempt, and we constantly look for ways to improve the efficiency of our building methods. One thing we learned was that PET, polyethylene terephthalate, plastic filaments, are better than other commonly used 3D printing filaments like PLA and PETG. They have more resistant to weather and physical impact and have more tensile strength. Here are some products people have created using recycled PET filaments at Copincha. Art objects, a holder for securely mounting phones on bicycles, components that can build and repair other machines, and plastic screws and clamps. Our experience taught us that designing and creating 3D printed products with recycled plastic filament is more accessible to the wider public when the following principles are prioritized. Simplifying designs. The simpler shape and manufacturing process, the easier it is for the people to replicate. Extensibility. Creating items that can be used for a long time, serve additional purposes, or adapt to changing needs. Versatility. Designing pieces that can be manufactured using a variety of processes and materials. Self-replication. Machines that can reproduce versions of themselves. Standardizing the materials used and documenting them. Using a single type of plastic for plastic products and properly marking them to indicate the type of material used. Disassemblable design. Designing item components that can be easily separated, allowing users to replace broken parts without discarding the entire product and reuse parts in various products. Now I will share how I've applied these lessons and practices that we developed in Cuba in the context of the NYC Resistor hackerspace, where I construct a PET filament extruder in the fall. First, we labeled the basket for people to place discarded bottles. This created our steady source of recycled plastic, which can be fed into the PET filament extruder to create plastic filaments. I'm trying to make this version of the PET filament extruder easier for a wider range of people to build. Router milling, laser cutting, and 3D printing are three building methods available at both Copincha and NYC Resistor. One common aspect of all these construction methods is the fact that 2D vector editing can be used to create flat shapes with each. This was my starting point for developing a basic, shareable construction design that people can adapt in different, more complex ways. To define size, shape, and connection of my flat components, I used the Open Structures Grid. It is a widely used modular design system that allows different parts to be combined into new creations. In this way, elements made from different materials can be reused in the same project as long as they all follow the parameters of the grid. This grid is based on a 4x4 cm² that can be divided or multiplied, maintaining compatibility between the parts. The Open Structures Grid allows us to break down the system into smaller reconfigurable models. But we can also consolidate parts into larger and more complex forms. We can also integrate universally standardized components into models. Also, using flat piece designs simplifies the 3D modeling process, which only needs to add height to the 2 shape to make a 3D piece. I've automated this using OpenSCAD and a Python script, so the entire process now revolves around creating a 2D vector and passing the 2 design to the manufacturing parameters setup process. Here's the machine in its current state. I hope these experiences serve as inspiration for others to develop sustainable and accessible open hardware solutions, whether for plastic recycling or addressing other social challenges. Above all, I hope people are inspired to actively participate. Thank you very much.